Guys, welcome to my YouTube channel. In this video I am going to teach you about surface chemistry. Before entering into my channel, please subscribe my channel and like. If you like it, please like my channel. If you dislike it, no problem, please describe my channel and comment what's the problem in my video, and your comment will be helpful for me to develop my channel. If you need any videos also, you can comment me in my comment box. I will upload it as soon as possible. Okay guys, in this video we are going to see about surface chemistry. In the chapter name itself we can able to see surface. In this chapter we are going to see about absorption, absorbent and absorbate, these things, and what are the factors affecting them, what are their users, and like that, why they are happening, factors influencing absorption, characteristics of absorption, something like that we are going to see in this chapter. Let's go ahead guys. First of all, some definitions we want to know before entering into the chapters, then only we will be clear about the terms used in the chapter. First of all, we see the definitions for some terms. Adsorption, what is meant by adsorption? The phenomenon of concentration of molecules of a gas or liquid at a solid surface is called adsorption. You can see there are two types of adsorption. I will explain it them further. We are going. There are two types of adsorption. One is physical adsorption and chemical adsorption. Adsorption means phenomenon of concentration of molecules, gas or liquid, at the solid surface of the solid area. It's called adsorption. In other terms, adsorption of gas on solid is sometimes called as oscillation. Adsorption of gas on solid is known as adsorption, physical adsorption and chemical adsorption. You can able to see the physical absorption and chemical absorption. What is meant by physical absorption, what is meant by chemical absorption, I will explain you later. Just we can move to adsorbate and absorbent. What is meant by adsorbate? The substance which is held on the surface of the solid is called adsorbate. You can see the arrow, it near adsorbate, it is on the substance on the surface. The definition also, the substance which is held on the surface of the solid is called absorbate. You can able to see. And absorbent means the solid that takes up a gas or a solute for the solution. The solid that takes up the gas or solute for the solution is called absorbent. They will allow the molecules to pass through the minute pores. They are called as absorbent and they will go inside to them. Just next I will show you the example for that. Okay. Adsorption, I had given three different pictures for you. It's showing adsorption. Adsorption differs differs with the surfaces, absorption and reflection of light. And this thing I had been taken for you. It will be very easy for you to understand. Absorption. You can see the black. Third picture. An object is seen as black if it absorbs all colors of white light. It's absorption. It absorbs all color of light, and in absorption the molecules are distributed evenly throughout the surface. It is known as absorption. Okay, throughout the body. Okay, next we will go to types of absorption. In absorption is the process which a substance is uniformly distributed throughout the body. You can see in this, it will uniformly distributed throughout the body. Absorption or adsorption, it depends upon the material which we are using and the gases which the characteristic of gases. It depends upon everything guys, including temperature, pressure, like that also. Just we can move to other chapter. Next one, explain it you clearly. You will get understand when we go further. Types of adsorption. Before types of adsorption, want to know about something. Adsorption is a surface phenomenon because the molecules which they are the molecules are held on the surface, so it is known as surface phenomenon. But absorption, they are uniformly spread throughout their body, so it is called as bulk phenomenon. Adsorption is a surface phenomenon and absorption is a bulk phenomenon. Adsorption is a rapid process and adsorption is a adsorption is a rapid process and absorption is a slow process. Equilibrium is attained easily. In adsorption, equilibrium will be attained easily. But in absorption, equilibrium will attained slowly. It will take some time, sir. The concentration of the molecules are more on the surface. In adsorption, the concentration of the molecules are more in the surface. You can able to see all the concentration of the molecules are in the surface and less in the bulk. Only little. What are the things they want only they will allow through adsorbent. So it will be less in bulk. But in absorption, the distribution is uniform. Okay, we will go now move to the types of adsorption. Physical absorption, chemical absorption. Okay. What is meant by physical? What is meant by chemical absorption? Physical absorption is the one in which the absorbed molecules are held on the surface of the adsorbent by a weak physical or van der Waals force of attraction. For example, we can give adsorption of H2 or O2 on charcoal. Charcoal absorbs H2 or O2 very easily, held on the surface, does not left them to go inside and combine with covalent bonds or chemical bonds. It will leave them in the surface with a weak van der Waals force. Physical absorption is one which the absorbed molecules are held on the surface of the absorbent by a weak physical or van der Waals force of attraction. Chemical absorption means same thing, only one thing will difference. Chemical absorption is the one in which the absorbed molecules are held on the surface of the absorbent by a chemical bonding. In that, held on the surface of the absorbent, in physical absorption, held on the surface of the absorbent by weak van der Waals forces or weak physical or van der Waals force of attraction. Chemical absorption, they are held together by a chemical bond, covalent bond or ionic bond. Example for that is absorption of H2 on Ni. Okay guys, just we can move to next thing. I will explain about physical absorption and chemical absorption clearly next slides. In this we will see about physical absorption clearly. There is a relationship between physical and chemical absorption, guys. In physical absorption, the molecules are held on the surface of the absorbent, but in chemical absorption, they are held on the surface of the absorbent. Adsorption, they are held on the surface, but they are in physical absorption, adsorption are reversible. Chemical absorption or chemical adsorption. Sorry, guys, it's adsorption or irreversible. First, when hydrogen goes with, I will give an example for you guys. H2 molecule is first absorbed by van der Waals force of attraction. With Ni, H2 molecule will first go through a physical adsorption by a weak van der Waals force of attraction and then undergoes dissociation to hydrogen atom and then it will go to dissociation to hydrogen atom. Then H atom with Ni will form a bond between a hydrogen atom and Ni. Okay guys, first it will, you want to know the steps. First it will come attach with like van der Waals force of attraction with like physical absorption. After that only they will turn into chemical absorption. This is an example for H2 and Ni. Okay, when we go to next means there are I had given some difference between physical absorption and chemical absorption. The force, let's see guys, the force of operating in this case the weak van der Waals force. In this it is caused by an intermolecular van der Waals force. Physical absorption is caused by intermolecular van der Waals force and chemical absorption is caused by chemical bonding. It's a strong bond, this is a weak bond. In physical absorption, van der Waals force is weak bond and ionic bond or covalent bond or chemical bond, commonly it's a strong bond. Heat is absorbed is low. Heat is absorbed is low in physical absorption. It's 20 to 40 kg mole minus 1. In chemical absorption, it's high, 4 to 40 to 400 kg mole minus 1. The process is reversible in physical absorption, and in chemical absorption, the process is irreversible. In physical absorption, the absorption decreases with increase in temperature. When the temperature increases, the physical absorption will decreases. While in chemical absorption, the absorption increases with increase in temperature. Okay, guys. Next, multi-layer absorption occurs. In physical absorption, there will be a multi-layer because they are uniformly distributed throughout the body. So, multi-layer absorption will occur. But in chemical absorption, physical absorption, multi-layer absorption will occur. But I will say why I said they are distributed throughout the body for absorption. But here we are not talking about absorption. We are talking about adsorption. In this point, you just keep it in your mind. I will explain why multi-layer absorption occurs in physical absorption, and monolayer absorption occurs in chemical absorption. I will explain it my next slide with a clear picture. Okay, the rate of adsorption increases with the increase in pressure and concentration in physical absorption, and the rate of the adsorption decreases with the increase in pressure and concentration. This also I will explain you. Equilibrium is estimated as established rapidly. I had been said in my past slide, and but it requires time. Equilibrium is attained slowly in chemical adsorption. It requires some time. No surface compound formation takes place in physical absorption. Surface compound takes place because in physical absorption they are attracted through an van der Waals force. But in chemical absorption, they are attached with a chemical bond, so they form a surface compound. But in physical absorption, they does not form a surface compound. It involves very small activation energy. It involves very small activation. I will say what is meant by activation energy. Just wait, guys. Just know about difference between them, and I will explain it. What is meant by activation energy and all in my next slide and all. It involves applicable activation energy for chemical absorption. It is not specific in nature, physical absorption, but it is highly specific in nature, chemical absorption. Okay, guys, just we will move to the next slide. Okay, next slide, factors influencing adsorption. In this only you will came to know about the things what I had been saying, activation, absorption. In this, I didn't give the point, 8th point. There will be another point, activation of adsorption. But I will explain about it, guys. Don't worry about that. First one, adsorption and the surface area. First thing, we want to know about the factors influencing adsorption. First thing, what is the characteristics of adsorption? First thing, we want to know the characteristics of adsorption, guys. Adsorption, characteristics of adsorption. Just adsorption on the surface is always spontaneous thing. It is adsorption is always accomplished by the evaluation of heat. It will release just a minute, guys, I will say you it will wait. The energy liberated when 1 gram mole of gas is adsorbed on the solid surface. The energy will be liberated, guys. So only the evaluation of heat occurs there. The absorption accomplished by both by decrease in enthalpy and entropy of the system. The adsorption is a selective process. Adsorption, you itself know, the molecules are held on the surface. Only the selective molecules are lived inside to them and through adsorbent. So it's a selective process, but in absorption every molecules are distributed throughout the body, guys. In adsorption it's different, opposite. The rate of adsorption depends on temperature. Like we had been seen with increase in temperature, increase in adsorption. Adsorption in chemical absorption, adsorption is a physical phenomenon but accomplished by a chemical change. Adsorption is specific. It depends upon the nature of the absorbent and the absorbate. Depends upon the nature, guys, about the surface absorbent, which surface it is absorbing, and the gases, which gases we are using there. It's very very important, guys. This we will go throughout the absorption of gases on solids. Now we are going to see about the absorption on gases on solids. Okay guys, first thing we want to know about this is nature of gases. While all solid absorb gases to some measurable extent, not more, only some measurable extent, the magnitude of the absorption of the gases by the solid depends upon the following factors. Nature of the gas, it's very very important, guys. These 7 steps, not 8 steps, is very very important. First we will see about the nature of the gases. It's the main thing. Nature of the gases, the amount of the gas absorbed by the solid depends upon the nature of the gas. The amount, you can see in this picture, they are observing all the molecules. The amount of the gases absorbed by the solid depends upon the nature of the gas. Not only nature, guys, depends upon the nature of the surface of the absorbents also. First, in this nature of the gases, we want to know this. Some gases are easily absorbed and some are very difficult to absorb. I will say the examples, just you can note it, it will be helpful for you. Easily liquefiable gases are absorbed more easily than permanent gases. Liquefiable gases, example HCl, NH3, Cl2, SO2, etc. like that, guys. And like permanent gases, H2, N2, O2, etc. Okay guys, next thing we will go for critical temperature. Next thing is in this we will have one more subdivision for natural gas. It's a critical temperature. Yes guys, critical temperature. What is meant by critical temperature? You want to know about that first. The minimum temperature above which a gas cannot be liquefied. In case of liquefaction depends upon the critical temperature. Thus, if the critical temperature of the gas is more, it will be liquefied and absorbed more rapidly. If the critical temperature is high, the gas will liquefy very fastly and it can be absorbed by the absorbent rapidly. But if the critical temperature very low, means the gas will not converted into be liquid, so it cannot be easily absorbed by the absorbent. This is the thing, guys. Next thing we will go to Van der Waals force, second subdivision. Easily liquefiable gases possess a greater Van der Waals force and permit gases so that they are Van der Waals force of attraction. Easily liquefiable gases possess a greater Van der Waals force than permit gases, so they are absorbed more readily. Next we are going to see nature and surface area of the absorbent. Absorption and surface area means in first point we are going to see this. Since the absorption and the surface phenomena, absorption is a surface phenomenon, we know that the extent of absorption depends upon the surface area. Absorption had been told before itself. Absorption does not depend only in nature of the gases, it also depends upon the surface area. The greater the surface area, greater is the absorption. For example, I will say one thing. If you are spill some water in the floor, you are using sponge. If you are using sponge to absorb the water, if you are using tiny sponge, means it will take some time to absorb all the water. The bigger sponge, within a few minutes, a few seconds, you can able to absorb all the waters through the sponge. It's same thing. You can have it as an example to remember this. The greater the surface area, greater is the absorption. Larger pores on the absorbent, larger is the absorption. This is because pores permits the diffusion of gases. Okay guys, next we will go to the, I will give another one more examples for you. Larger pores will permit larger, you can see here, larger pores permit diffusion of gases. The pores is larger means the diffusion of gases is more, but the pores is smaller means the diffusion of gases will be less. Charcoal and silicon. gel will be an example. Charcoal and silica gel. These are excellent absorbents because their structure is highly porous and possess large surface area. Charcoal and silica gel. Okay, next thing we will move to heat or enthalpy of adsorption. Heat or enthalpy of absorption. Heat or enthalpy of adsorption, there are physical absorption and chemical absorption. They are separated into physical and chemical absorption. Due to van der Waals force, physical absorption, the attraction between the gas molecules and solid surfaces are relatively weak force. Due to van der Waals force, the heat of the adsorption is very small. So only the heat of the adsorption is very small. If the heat of the adsorption is very high in physical adsorption, means the adsorbed molecules will be very less. But in chemical adsorption, the attractive force are due to the formation of chemical bonds. The heat of the adsorption is larger. Larger means it can absorb more thing. But no, we should not increase temperature continuously. After a certain temperature, the adsorption will decrease. Gets to decrease. Next, we will go to reversible changes. Reversible characteristics. Fourth one, we see in the heat. The third one, we will go to the fourth one. Reversible characteristics. In this also we are having a physical absorption and chemical absorption. Physical absorption, gas plus solid, gives have been given the equation. Here you can able to see gas plus solid. It's a reversible equation. Gas plus solid means in physical absorption it is a reversible process. The gas adsorbed on the solid can be removed or disadsorbed under reversible condition of temperature and pressure. You can able to before I said you can remember that, recall that, means you can able to know this. If the temperature in physical absorption is low, they can absorb more molecules on the more molecules. If we increase the temperature, all the absorbed molecules will be become disadsorbed. So it is a reversible process, but in chemical adsorption is not reversible process. Chemical adsorption is a reversible. Here you can see I had been given a charcoal example for you. Already I had been given a charcoal and silica gel as an example. Like this only they will happen. Molecules are created on the surface of the phase. Molecules are drawn into the bulk phase. Is mean by absorption. This is adsorption. Okay, guys. Next we will move to effects of pressure of gases. Pressures also plays an important role in this. Sixth point. If you take pressure means this picture. Pressure means since the dynamic equilibrium exists between the adsorbed gases and the gas in contact with solid, increases the pressure, increases the adsorption of the increases the absorption. Decrease in pressure, decrease in pressure causes disorption. For example, in this I will give a different example for you to understand. You are having you guys had seen soda, I think so. It will have carbon monoxide in it. At certain pressure, the gas dissolved in the liquid. At a high pressure, the gas dissolved in the liquid will be high. When you decrease the temperature also, it will dissolved molecules or gas will be higher in the liquid. You are using pressure to dissolve the carbon monoxide in liquid. Is a great example for it. With increase in pressure, the increase in the adsorption will be increases. With decrease in pressure, the adsorption will be decreases. Okay, guys. Next, we will go to effects of temperature. The fifth thing. Now, pressure we see. Sixth, we will go for the fifth thing. I have said you the physical absorption. Increase in temperature will. In physical absorption, it occurs rapidly. Lower temperature decrease, and the decrease with increase in temperature. You have the temperature is less, means the adsorption, physical adsorption will be high. The temperature will be high, means the physical absorption is less. You can see the graph shown. But in chemical adsorption, if the temperature is high, means the graph will increases for certain distance, and it will gets to decrease. It will increase with increase in temperature and then start decreases. The thing, guys. Next, we will move to thickness of adsorbed layers of gases. We will move to the thickness of adsorbed layers of gases. Okay. This Laminos, I will explain that Laminos theorem and equations in my next video. If you want, you can see that video. It will be helpful for you to understand this. Shown that that at low pressure, the physical adsorbed gases forms one molecule layer, but above certain pressure, multimolecular layer. At low pressure, at low pressure, in physical adsorption at low pressure, they will form in this you can able to see, I think so, in physical absorption you can able to see at a certain pressure they will form a single layer. You can able to see there are single layers, but in increase in temperature they will form a multi layers, thick layer formed. But in chemical absorption there will be a single one molecule thick, since one molecule things since chemical adsorption takes place with the adsorbent surface only directly. First physical absorption will occur, then only chemical absorption. I had been explained you before. So it's adsorbent surface only directly. Okay, next we will move to activation of adsorption. In this you can able to see, I had just a minute, I had said almost point. In this you can, if you want, means you can add some more points. It involves very small activation energy in physical absorption. Chemical absorption, it involves applicable activation energy, and in physical absorption it is not a specific in nature. In chemical absorption, but is highly specific in nature. You can, if you need, means you can add these 2 points also, because we are seeing about activation energy in activation energy. In this it will be an your 8th point, activation energy. It is not given in that, sorry for that. I will say, I will explain it. You don't want to worry about that. I will explain about it. Activation energy. Yeah guys, activation energy leads to increase in the surface area. Activation energy, you can able to see this. I had been said sponge example for you like that. If the area is larger, means the water will be absorbed by the sponge very easily. If the area of the sponge is smaller, means it will take a few minutes. Same thing in the activation absorbent. Activation leads to the increase in the surface area of the absorbent, which increases the adsorption. Activation is achieved by following, I will say the things, by mechanically rubbing the surface of the solid absorbent, and by subjecting to small some chemical reaction on the surface, solid surface. Chemical reaction help us to help in it, or by subdividing the solid absorbent into fine small particles. It will absorb more water in the shape by or by heating the solid absorbent to superheated steam. Now its pores are opened and the absorption in superheated steam, the absorbent pores or will be increases their size, so the absorption will be higher. Okay guys, thank you for watching my channel. Please subscribe and comment my channel. Okay guys, let's see, I will see you on another video. Thank you, bye.